I don't know whether I mentioned that name. 74157 is a 4, that means quad 2-to-1 multiplexers. So you require 2 such 2-to-1 multiplexing arrangement over here. One is for the write enable, and the other one is actually for that clock, for that counter. I think we are mentioning that the clock.
Sir, the final the output of the inverter that we designed, like after inverter will use 2 buffers and 1 AND gate. That output will go to the clock, like input of the 74192, right? And it will be like connected with a switch to the clock.
Okay, there for that clock, I think both will work. Either you give this one, or you give the other input. Other input means you can directly connect it to in any of this location. That will also work. But anyway, in my design, I have connected that pulse finally to that clock as well, I guess. Yeah, from the output only. Where is that clock? CPU. Yes, I have connected it from the AND output only.
And sir, the enable part, that will also go from the AND output. And sir, like I had a doubt, sir. In the ASCII keyboard, when you will be inputting, like for displaying E, you will be using 14, right? So like, how will he enter 2 digits at the same time, or will just type E in the ASCII keyboard?
Come once again.
So like when you will be displaying E, for that the number will be 14, right? That will be entering in the ASCII.
1110, right? 1110. So here other 3 bits, I think you are not taking them. So what you need to do is to check out the ASCII code where you are having something like this. Okay, so most probably capital N or something. E won't give you this one. I think I should have mentioned that. So because all one, I remember yesterday I was testing, I was giving capital O. So just one less than that, that is capital N, right? So if I give capital N, then I would get 1110. Okay. But then actually there is a little bit more automation we can do. Say in the lab, actually people used to do that. You can certainly do that in the simulation also. That rather than having any switch which is to be manually controlled, everything should be controlled by your keypad. So that is supposed to happen if you give something to your user, that there might not be many switches and all. So you will get them from the keypad only. So in that case, it may so happen that I mean, whatever the students used to design in the lab, let me tell you that whenever they enter a number, so rather than roll number, we used to say that, okay, enter your mobile number or some such number, so that it is restricted to the numbers only. Okay, so then it becomes easier. So if you press any number, then the display mode will be stopped. So in other words, it will enter into the write mode, and then you can write. Then once again, if you press any other character key other than that 0 to 9, so then it will go into the display mode. So here also you can try that one. If you can utilize any of this unused bit, that whether you have pressed something with this bit 0 or this bit 1, because some of the bits will be 0 if you press that 0 to 9. But some of the bits will be high if you press a alphabetic character like M, N, O, P, or whatever. So if you can use anything else, then you will find that you can change that multiplexer that we are talking about, that multiplexer select line. If you change, it will change the clock input from your AND gate output to that pulsar output. Similarly, the write enable side also, rather than enabling it, I mean, rather than keeping connected with this one, you can connect it to disable means basically high, logic high. Okay, so there will be 2 lines connected to that multiplexer. One is for deriving this write enable and this enable line. The other one is the clock source for 192 or 193.
So where are we using the first enable for write enable and what?
Write enable and this enable for this buffer. They are tied together really.
Yeah, so why do you need a multiplexer for that?
Multiplexing is to change from read mode and write mode. That whenever you are in the read mode, at that time, I think it must not work with that. So you may make it high at that time.
But we are doing that with the strobe signal, right?
You are doing that in the strobe signal, but what will happen, suppose if I press some other character, at that time we don't want that to go into the write mode once again. Suppose that P, Q, R, S, whatever I am saying, if you press any of those, I do not want to write, I just want to get into the display mode. So at that time the strobe signal should not reach the write enable or this enable. So that is the idea, that if I press any other key 0 to 9 and any key other than 0 and 9, then this should not be write enabled. So that is just interpreted as a command. So now you can decide your own command, that suppose if you press D, maybe it is for display, or if you press something P, then it will enter into the programming mode. Okay, so there are so many possible variations that you can think of. But initially I would ask you to do it manually, maybe with 2 or more number of switches, so that you feel more comfortable about that.
Sir?
Yes.
So could you please repeat the part where you said the inverter and the logic switch for write enable shouldn't be working together, because then inverter won't be working independently? That I couldn't understand.
Okay, so let me just check out that one where we are drawing this slide, I guess. So
Yes.
maybe it's not visible. So there, what I did before drawing this black line, it was just this write enable is connected to a switch, so that I can control manually whether I want to write or want to read. Okay. Now I said that okay, I can generate this write enable signal from the strobe signal. Here I have actually drawn a single inverter. In lab, its single inverter would work well, but in this case, as I have shown, that you require 2 more buffers and an AND gate to widen the pulse. So if I use an inverter, so now I am no more dependent on this manual switch, right, for making this into the write mode or read mode. So it will come automatically from the ASCII keypad. Whenever I press a particular key, this inverter will generate a lower going pulse, and that low portion of that pulse will make it enable as well as make the buffers enable. So at that time, unless I get rid of this manual switch, what will happen? If I keep it to this position 1, then if the inverter output, whenever it tries to make it low, it won't be able to make it low because I have already connected it to 1. So whatever it is, 1 or 0, if I connect it to a constant value, the inverter cannot change that line's status, right? So that is why I said that if I put the inverter at that time, if I keep the switch, there will be contention, that when it tries to pull it down to low, maybe I kept it at high location. Or if I make it permanently low in this switch, then it won't be made high through the inverter output. So these two should not be simultaneously placed. If you want a manual connection, do not put the inverter or do not use the strobe signal at all. Do it manually. And when you try to automate that through the ASCII strobe signal, connect the inverter to this line, remove the switch. So I don't know whether it clarifies the doubt.
Yes, sir. So when we are using a manual switch, then I think counter will always be connected to the usual clock. And
Yes.
okay.
So yes.
So like when you'll be using the switch in the write enable, then like shouldn't we use the buffer? That thing, like, can you repeat?
When I use the switch,
When we are using the switch in the write enable part, like at that time, shouldn't we use the inverter in the ASCII?
no, at that time, if I use a switch and inverter simultaneously, because switch is actually setting this line status to a specific constant value, either a 0 or a 1, right? So if I use an inverter over here, I'm talking about this blue inverter only. So this blue part and whatever I have encircled in this blue, either I have to use that circular, inside circle, whatever I have drawn, that is switch, or I have to use an inverter, but not both. Because inverter will try to change the status of the signal, sometimes high, sometimes low. And switch, I try to change the status manually, so they won't match. So if I put the switch either at 1, it will always remain 1. This one won't be able to pull it down to low. If I keep it at low, it won't be able to make it high. So there will be contention between the intention of the inverter and whatever I have kept in this switch. So either of this one has to be used. So I suggest that initially you may use the switch to check manually that okay, whether write operation is taking place or not. And then once you are satisfied, then you remove the switch, connect it with the inverter.
Sir, when you will be using the switch, at that time we can directly connect the strobe signal to the input of the counter, right? like through the switch, through the like SPDT.
Come once again, I could not follow completely. You are talking about this side, right? This switch.
Yes, sir. Like when you will be using no. I'm telling about the switch in the right enable side.
Okay.
When you will be using the switch in the right enable side, at that time we don't need to use the inverter, right? So the ASCII.
Right. At that time, we are not using the strobe. We are just
Yes.
controlling this right enable as well as the buffers enable signal through the switch alone.
Yes, sir. So, sir, at that time we can directly connect the stroke signal of the ASCII to the input of the counter, right? Through the final switch like SPDT.
One second, maybe I'm missing whatever you were saying. At that time means when you said that you are connecting the switch, not the inverter, right?
Yes, sir. Yes, sir. At that time.
At that time, now repeat that last part.
So at that time, like what should we do with the stroke signal of the ASCII?
Just keep it open. I mean, don't use it.
Okay, okay.
It will remain open. Don't connect it.
Sir, like when we are using the switch with the right enable, so what is the inputs of the, like we have two possible inputs, right, for the counter. One is clock and one is another thing which is coming from the stroke signal. So during that case, like what will be the second input for the counter?
For the counter,
Yeah.
second input means you are talking about the clock signal, right?
One is clock signal, another one is we are taking from the, while we are writing, we are taking from the stroke signal, right? For ASCII. So like when we are not using the ASCII stroke signal, instead we are using the switch, manual
Right.
switch.
Right.
So in that case, what we will do, like what will be
This
the
is at that time I assume that you do not have any pulsar. So this is directly connected to the clock signal. So either through this switch, I mean, when the switch is connected at that time by throwing the switch off and on, you can generate a clock signal.
Yeah.
Or else, as you are suggesting, that maybe I can use that inverter and generate the clock signal. But once again, I would suggest that, okay, whatever you decide, do it just from the same signal. Either you use this or you use this. So your right enable, this enable for the buffer as well as the clock, you derive from the same source. Either it will be a switch, because throwing the switch off and on, that will also change this. Or alternatively, if you feel that, okay, you need not have to connect this one, you can just connect a switch at the clock point, which is going to high and low. You need to just toggle it once to make the counter advance. Okay, so you can do that one also if you wish.
Okay. Also, so one more thing, like why did we extend the length of the clock signal initially? Can you just tell that once again? Like,
It is actually because of the problem of the simulator. That simulator, everything is coherent. Coherent means it is dividing the clock's pulse into 10 time unit called ticks. And some signal, for example, this strobe signal, it is remaining high only for that one tick, that is 1/10 of the clock's period. Okay, so for writing, what this RAM is expecting that, okay, we will make that write enable active, and after one cycle or two cycle, I do not remember exactly, the simulator is working. So after some time, maybe one cycle, one tick, then whatever you put over here, that will be written. So it actually takes more than one tick for this write operation to get completed. Because the first thing is that it has to release the bus, it will be tri-stated. Otherwise, earlier it was using as an input signal, and it's an output signal from this. Now I want it to be an input signal. Changing that one takes one tick, then writing takes another tick. So it is not happening in just a single tick period if I keep that write enable active only for such a short time. So I am widening that. In practice, I think in the lab, whatever keypad we are using, that is having somewhat longer or wider pulse. So in that lab, I think we do not face this issue. But here, everything is idealized. So it put just one tick for this strobe signal. So that is not becoming sufficient for the RAM model that it is using. So I need to switch it at least by 2 cycles or 3 cycles.
Sir?
Yes.
So like when I'm using the switch in the right enable and the RAM is in the right mode, at that time, where will be the input of the counter connected? like the clock input of the counter.
For this writing operation.
Writing operation using switch in the write enable. At that time, where will be the input of the counter connector?
Initially, you may connect a separate switch also, that if you just change it once, then you see that, okay, the counter is advancing by a cycle. Or else, I think I would suggest that if you do manually, then that will be better. Or if you connect it like this, then you need to write disable and enable once again, so that it generates a clock. Yeah. So if you keep it always high, it may not generate that one. So you need to press a key in the ASCII keypad. You need to manually switch it once. So then you can have that one also.
Sir, and what, like, is there any IC which has the tri-state buffers, or like what?
Tri-state, right? Tri-state buffer. I think we are using this type of buffer is known as 741. This active low and active low, I think, is 25. Active high is most probably 26. Just check. I might be mixing up. 74125, I think, is active low. 126 is active high, or it might be the other way around also. So please check. I think I am having that schematic. Just let me open and see. Yeah, 125 is having active low enable. So 74125 you can use. It contains 4 such buffers. Though I think if you put no, I think it is coming as a single IC. But the control lines you need to connect. It is having separate control lines for each of these buffers. So you need to connect all 4 together to make a common control line.
Sir, and the SPDT that we will be using, is there any specific name, or we can get it by typing like SPDT?
You can get it under switch, I guess. হ্যাঁ, ক্লাসে আছি। হ্যাঁ, মিটিং ডেকেছে আমাদের ওই 5টার সময় ফিজিক্যাল মিটিং বলেছে, সবাইকে মেলটা পাঠায়নি হেড। না না, মেল পাঠিয়ে দিয়েছে কিন্তু সবাইকে ডাকেনি। আর তুমি এটা জিজ্ঞেস করো একবার, ওটা ভুল করেছে মনে হয়। জিজ্ঞেস করে না একবার হেডকে ফোন করে। হ্যাঁ হ্যাঁ, জিজ্ঞেস করে না একবার। আমার ক্লাস চলছে এখন, আমি পরে কথা বলছি। হ্যাঁ, ইয়েস প্লিজ। হ্যাঁ, আচ্ছা। হ্যাঁ, so any question you are asking?
Yeah. So like when you said that control input, you're talking about enable, right? For the tri-state buffer.
Okay.
So are they both different, or like?
Control means that enable only. So for the tri-state buffer, control means that enable signal.
So in place of using a multiplexer, can we make it conditional on the ASCII character that we are inputting?
That is what I am saying, that use a multiplexer, but the multiplexer select line, make it conditional, that if you press a specific key, then only multiplexer select line will be high or low, something like that.
Okay.
So do we have to like not use the switch and use the Stokes signal?
Okay, just one moment, but then I will be actually sharing that. But anyway, you can practice that. Just let me see whether I can share my screen. How many
So
students?
for the clock also we'll use the multiplexer.
For clock also we'll use the multiplexer.
And the select line will be manual, or
Just wait for a moment. Let me see that, okay, whether I can share my screen. But with 100 people, if I share, I do not know, sometimes it crashes. In the other meet who are there, Avishkar, Mukul and Ansari. Are you there? Your voice is not coming. Mukul Kumar. Just turned the meeting on and left. Avishkar?
Yes, sir.
So can you join the other meet, because probably I will not be able to share the screen with the 2 meets. So can you just leave this meeting? You are having the code for other one, right?
Yes.
So please, if you join the other one, I will try to show you also. Okay, so let me see whether it works. I'm sharing my screen. Sometimes it crashes. So, is this thing visible? Just let me see whether I can connect from another machine and see whatever is there. Is it visible? So if it is visible, either say yes or say no.
Yes, sir.
Yes, sir.
Okay, so this is something where it has been done manually. So let me just see whether I can make out what I did. So first of all, this arrangement, I think you can understand that this is for the strobe signal, inverter followed by 2 buffers and gate. So I am getting a wider pulse over here, right? So I'm feeding that to this pin. Achha, here it is slightly different. I was experimenting initially with a 374 with a register. 374 is almost identical to your what is the register you have been using? 273. But it doesn't have a master reset. Rather, it is having a tri-state provision, that OE bar. So I initially have connected this. You can replace it with a buffer also. So doesn't matter. Don't put it in your head that okay, why I am using 374. Consider it to be a buffer for the time being. Then I am having this RAM. I am only using this 4-bit of data line. Address is coming from that 193 as I have mentioned, with parallel load and down counter. The down count clock connected to logic high. How many switches I'm using? Just let us see. Here is one switch. This is for master resetting the counter, right? So the counter I can reset. There is another switch here, but what is this? Can you see that? I'm probably having another circuit also. This is a multiplexer. Just let me see that whether I can have something else. Not remember the names. No, this is the basic RAM circuit. This is something I think how you can test a chip. This is the first circuit I have made to check the chip. That these are RAM 1K. I have used a hex keypad for generation of the address lines. I am having another hex keypad for through that buffer for generation of the data, and then I'm just testing this one. But anyway, that is not the one. So let me go back to what I was showing. So RAM buffer. I think if I use a buffer, maybe this circuit. Okay. So here I have changed that to a buffer. So this is the circuit I was looking at. But here you may see that I have used 2 switch. One is for resetting this counter. Another switch. Can you identify this thing? What this thing is? These are multiplexer. These are multiplexers. So look at it carefully. I think it is visible in this resolution. You can make out what is there.
Sir?
Yes.
So like, can you explain the pins of the buffer IC? Like, which is the enable pin and which is the
okay. So this is you are talking about with respect to this one, right? Pin diagram.
Yes, sir. Yes.
Okay. Here this A is the input, C is the control or this enable line, Y is the output. So that is the general convention. ABCD is typically the input and Y is typically the output for combinatorial circuit. So there are 4 such 2-to-1 multiplex, 4 such buffers. So the buffer input for one is called 1A, the output corresponding is 1Y. Similarly, input is 2A, output is 2Y, input is 3A, output is 3Y, and so on, 4A, 4Y. And for each of them, the control line is 1A, that is the enable connected to the first buffer. Second buffer control line is called 2C, third control line is called 3C, then 4C. So there are 4 individual control line available, which I have tied together and connected to that pulse stretcher. So is it understandable now?
Yes.
Okay. So here, what else? The rest of the thing I think is self-explanatory. This part I think maybe it requires a little bit of explanation. So here this E, this is enable. So enable bar, I need to connect it to ground, otherwise the output will not be active. So this one I am making it, this is 74157, that is quad 2-to-1 multiplexer. I am just using 2 of them. One I am giving it CPU, that is for up clock, up counting clock. So where from it is coming, there are 2 sources, like YA, that is the A means multiplexer, they are numbering ABCD. So multiplexer number A that is having two input, I0 and I1, I0A, I1A. 0 will be selected if this S is 0, other line will be selected if F is 1. Same for others also. YB output will either take I0B or I1B depending on the value of S, and so on. So I am using YA and YC, these two multiplexers. C is going to this right enable. Okay, whether I will make right enable high or low, that is coming through two lines. So you see how I am selecting. Select switch I have controlled manually here right now. So this clock, it can take two different sources. If I make this one high, it will take from this pulsar. Otherwise, if this is low, where from it is taking, it is coming from this AND gate, I believe. Okay, so just look at that. Yes, it is coming from the stretched pulse. Okay, so these are the two probable clock sources. Now look at the right enable. Right enable, what are the two sources and why I require them? One source is this, when it is 1, you see it is connected to +5 volt. That is, at that time no read operation, no write operation should be there. Okay, so even if I press something at the ASCII keypad, that should be disabled. So by changing this select line, I can ensure that, so that the right enable line, if you see that if I, so when I should change to what, when I should disable the right enable line, that when this pulsar is active, right, the pulsar is giving this one, I am in the read mode. So you see that pulsar will become active. Look at the pulsar connection. Pulsar is connected to I1A. What does that mean? It will be active when select line is what?
Low.
No, yes, I1 means when select line is 1, when it is high. So at that time, when S is high, you see I am talking about this output C. There are two input lines, I0C and I1C. So when select line is high, that is at the read mode, I am connecting it to the power supply so that it will never be into the write mode again. Again means if I press the ASCII keypad, it should not enter into the write mode. Whereas the other one, that is I0C, that when I set it in the write mode, at that time, this is coming from the same AND gate, right? So this arrangement, I have made it like this. So you can do a separate arrangement also. I mean, you need not really have to follow this. So if I try to simulate that, I am clearing this one. So I need to first write. So for that one, where I should throw this switch to 1 or 0, what you feel?
0.
To 0. Okay, so I am throwing this switch to 0. Simulator is not yet active, so I am running the simulator. Maybe I can show this one. So I am just resetting this one because it is initialized, it is already reset, but otherwise I am supposed to reset this and then I release that. So now all the lines are 0. So now I press some value over here. So just I'm pressing some numbers, like let's say 9, 8 in the descending order I am writing. So I press 9. So it is not selected. Yes. Press 9. Okay, so something happened. You might have seen a blinking thing. Then I press 8. So see whether the counter has incremented after pressing 9. Can you see the counter output by this red and blue lines? So after I reach that, the counter has become 1. So if I press some more key, now it will be in the next location. So now I press 8. So see, the counter is once again advancing by 1 unit. Can you see the counter output? Can you interpret? So just look at that and tell me. Are you hearing? I do not know whether.
Yes, sir. Yes, sir.
Anybody can unmute and say.
Yes, sir.
Yes,
Hello?
sir.
Yes, sir.
Yes.
Okay. So okay. So then I am pressing 7. You see the counter is changing. I am pressing 6, I am pressing 5. It takes a little time, so I do not know whether I have pressed faster than that. 2, 1. Okay. Now suppose I press question mark. Question mark makes all the line from this hex keypad high. Okay, so let us see if I press question mark. So what is the use of pressing all high? What will be displayed?
Blank.
If I send all 1 into the 7447, what will be the display?
Blank.
So this
Tell
is
me
the
something.
ASCII keyboard, right? Hello.
It will be blank, right?
Hello.
So I send all 1 to the 7447. What will be the display? Okay. So yes. Yes. And there is a lot of network delay, I guess, because of this sharing. I can hear you. Are you asking some question? Yes. Yes.
So the keyboard, is that a hex keyboard or ASCII keyboard?
Tracking for a long time. You couldn't hear it.
This is ASCII keyboard. It is having a strobe signal.
So for the ASCII keyboard, if you
So
want,
now let us see. I have already written. So now I am changing the switch, the selector switch. Okay. So before that I may reset the signal, but it is already. Because of for the ASCII keyboard, because in the ASCII I am taking only the last 4 bits. You need to check in the ASCII code what are the things that gives last 4-bit high. But anyway, I think I need to stop the screen sharing. Before that, I need to show you that okay, what happens in the read mode. So I'm changing this switch. Okay. So hopefully, is it visible? I'm taking only the last 4 bits. You need to check in the ASCII code what are the things that gives last 4-bit high. But anyway, I think I need to stop the screen sharing. I'm changing this switch. You can see that the display is now changing. It is in the read mode. Let me stop sharing. A question I'm not being able to listen that. So basically, design is almost given. So just you need to check the. So this experiment, I say that it is trivial. Anytime you can submit it. Next experiment, we will be using this one in a slightly different way. Okay, so it will also be using similar RAM and all. So am I now fully audible, or still there are some network delay?
you're audible.
Earlier you could listen to me, or what I understand, because I'm not being able to listen to you, perhaps there is a lot of network delay. I mean, when I say the voice. Okay, fine. So
like, can you repeat what you said in the last 1 or 2 lines?
About that circuit, or I was telling you that because I have already shown you the circuit, so there is very less to do actually. Okay, what you need to do is very little thing left out. So you can just try to replicate that structure so that you know the details about how to write into the RAM and how to read from the RAM. Okay. So
for the multiplexers, do we need to use manual inputs like manual 0, 1 or?
Right now, but you can actually decode some of the ASCII characters and use it properly. That if you press a particular character, then only it will go into the display mode. If you put something else, then it will come to the so-called programming mode. You can change the data.
Excuse me, sir.
Hi, yes.
So using the extra ASCII character, we can skip one of the multiplexer as well as the need.
This is yes. So use it innovatively. I mean, as you feel, there is no such specific.
Sir?
Yes.
Sir, and for displaying that E, we have to enter capital N, right?
Displaying E, I think capital N will do, but some other character will also do. Perhaps I don't remember exactly. You just check the ASCII table. Maybe what is there? Slash, not slash. Something like that is there. Either less than or greater than. Something is there. I do not remember immediately. You just check the table. Because 0 is starting from 48, I guess. 1 is 49 ASCII character code, and so on. So if you stop at 9, it will give you something like 1001 in the last 4 bits. So if you go by another, say, I mean, which will give you A, B, C, D, E, F. So look for those characters. They are appearing after 9. Okay. So just look at that character, then probably it will become very apparent. Okay, so just let me tell you one or two lines about the next day's experiment. So I am posing a question. Suppose you must have seen multiple displays. Suppose in your calculator, calculator is how many digit display? Calculator is nowadays, I think they have replaced that 7-segment display with some alphanumeric, I mean that so-called dot matrix display. So or maybe the lower line is still a 7-segment. So maybe you are having say 10 or more such 7-segment display together. Suppose I take 8 of them, 8 is power of 2, easier to handle. Suppose there are 8 number of 7-segment displays. How many lines do you think you need to send it to this board if the board is away from your rest of the circuit? Because as normally happened in any kind of such large display like your display on a railway station, airport, somewhere it is in the remote location. So in such a case, how many lines do you think will go into this box? Can you count and tell me? If there are 8 such 7-segment display, I have drawn only 6. I assume them to be in 8.
64.
Okay, so is there any possibility of reducing that? Okay, so first thing, maybe we can reduce it to some extent. If we put 7447 on board itself, then maybe for each of them rather than 7, I can send 4 lines. So most probably Ajay is saying why is not for 32. So most probably you are thinking like that, that if I put 7447 also here, then it becomes something like 4 lines per character per board, 32 plus power supply lines. So maybe 32 plus 2, 34 lines I need to send. But can I do it, I mean, by relatively smaller number of lines? Suppose I put a 7447, but maybe I say that, okay, I can manage with maybe if you look at the connector, you will find 4 lines are going like this. 1, 2, 3, 4, 5, 6, 7, 8 lines are going like that. There are power supply lines separately. So I'm talking about only the bus, the information bus going from your board to this display. Other than that, whatever is the power supply, 5 volt or sometimes it is more, that is there. Maybe ground connection if needed, that is there. If you look at the 7447, how many 7447 you think there could be? 8, because there are 4 lines. But you may become astonished to find only a single 7447. Also, in some case, you may find that rather than 8 lines, there is another IC over here other than a single 7447, and rather than 8 lines, there are only 3 or maybe 4 lines are going. So 4 lines here, 4 lines there, plus power supply, 7447 and another very common chip. So could you guess how it can be done given this much of information?
Sir, with the help of mux, we can decide to which display we want to give that data.
It was not exactly marks, but okay, you are in a similar line. But how I can manage with a single 7447?
Very quickly cycling through all.
So the same 7447 output, all the lines are going to actually all the displays. Okay. So then what will happen? All the display will display the same number. Suppose your roll number contains several characters, 1, 9. So if I send 1 through the 7447, all the displays will become 1. That is not my intention. I want to put 1 here, 9 here.
So we can store it in a RAM, 7-bit RAM.
No, that I can send from here. RAM is not here actually. From RAM I will send. But here, yes.
Sir, for one-time instant, sir, only turn that on when one is being displayed the desired.
Yes. So when I send 1, at that time only I power up this one. When I send 9, all of them are getting that 9, but only I will power up this fellow. So in that way, when I want which particular one to lit up, I will place that number in the bus and make that particular display only active. Active means I will apply power supply only to that. So there will be some power supply control. Earlier you are using just a simple resistor to give the power supply here. Now they may come through a transistor. But anyway, this mixed signal simulation we may not carry out in this particular one. So there we may put something which ideally you should not do. Maybe the output of a particular IC we will directly connect to the power supply. I think I asked some of you not to do that. Most probably Orpon has submitted something, right? Where in your challenge problem you have connected the power supply of a 7-segment display to some logic output.
Sir, actually I did it in 2 ways, but
okay. But anyway, I mean, you did that, and I said that okay, that is not a good practice. But just to avoid the transistor here, for simulating, we will use that over there. But that will be the next class. Okay. So this is called a multiplex display. So if you're interested, you can just read about this one a little early before coming to today. I have exhausted the full time. So maybe as soon as possible, you can. I mean, you keep that one. I have not circulated that link yet. So I'll circulate sometimes maybe in the afternoon. Now I have to rush for a meeting actually. There is a meeting called by HOD. So maybe I'm stopping here right now. And then you have already seen. So just to get yourself familiarized with this, do not think about the specification, whether you should do it manually or something. If you feel, you can upload a small screen, what do you call it? Screen capture video or something like that.
Sir, so what will be the deadline for today's submission?
You tell me what should be. I'll circulate the form only at the night. I have not made the
by tomorrow night it will be fine.
Okay, fine. Take it.
Yes, sir. Then sir, tomorrow midnight, right?
Okay, take it. I'm not actually that much fanatic about these deadlines. Okay, so take it in that way.
Sir, also like, can you tell us the ICs, like list of ICs, like what about the RAM? Which IC?
Actually, in the lab we would use 2114, but here there is no such IC. Yeah. So here, what we will use, you will go. Do you have your simulator in front of you right now?
No, sir. I'm in a different laptop actually. Like here, it will work.
Okay, so you need to go into the devices where from you are browsing that. So you go into the device, then you do browse, and then probably you are choosing it either digital by number or digital by function. I do not know which one you generally use.
By number.
By number. So there you won't get the RAM. So you need to go the other one, digital by function. There you will find that in that sub menu called minor device class or something. There you will find a RAM. So if you choose that, now finally the device, there are two devices coming. One will be some CMOS series 4505, I think. The other one is simply said RAM 1K. So it won't give you any number like 2114 or something. It is not 2114 anyway, but 2114 is 4-bit wide, it is 8-bit wide. So it says it's a generic RAM structure. It is not specific to any commercial product. It says a generic RAM 1K into 8-bit. So, but I find it is very closely related to that 2114, excepting that bit width. Okay, so you may choose that. So device, browse, digital by function, RAM, then generic RAM 1K.
Okay, sir. Thank you, sir.
Okay, so then I'm closing the meeting now.
Sir,
Hi, yes, please.
so we should be submitting either of them, like manual or using multiplexer.
For manual, I think it is better if you can make a small screen capture video that how it should be operated, because if there are multiple switch and the sequence actually matters how you are because in a wrong sequence it may not work. So if I switch it incorrectly, then I may not be able to understand whether your thing is correct or not. Okay, so in
I think in Google Form, like there is some limitation on the size of the file that can be uploaded. So like if we try to upload a video, the size can be more. So like
yeah, that's true. But in that case, I need to see also how much space is left in my drive, because of all this online thing. My drive is getting. Yesterday, I have seen it is to be 85% full. So I have to do a little bit budgeting before allowing 10 MB. 10 MB will be okay, right? 10 MB for a video. I do not require very high resolution video, right? So, but I do not know whether they can change. You can share the drive link. That will be better. Then I think in the comment section, probably you can. So I think that suggestion is very good. Digvijay has suggested. So that will be right. So I think I need to move for a meeting. It's the time is also over. So maybe I can close the meeting now formally.
Sir, what if we perform the experiment using multiplexer, not using switch manually?
Whatever you.
Will that be fine?
Yeah, certainly.
Okay, sir.
so, sir, the deadline is tomorrow midnight, right?
Tomorrow midnight. Yeah.
Okay.